Hi, and welcome to Data 602 Advanced Programming Techniques. In this session, we're going to be covering core Python concepts. If you're not familiar with Python, and this is a video that you do want to spend some time with. If you are an intermediate or an expert with Python, then this is a video that you can probably skip. So let's get started. In this session, we're going to be using the Spider Python IDE. If you don't have this installed, you can look at the syllabus to get instructions on how to install this. The way to install it is to download the Anaconda distribution that will install the Spider IDE and several other packages and get you going pretty quickly. So let's get started with the IDE. Let's talk about what we see here. First, what we see on my left here is the area where you type in the Python commands or the Python script, and this is we'll be using fairly heavily to edit our code. And on the bottom right here is the Python console. This is where you kind of interacting with the Python directly. So the script here is fed into Python, and here is where Python executes the script, and we have input or output from the Python engine. And so if there's an error or there's some output, we'll see it over here. Right above it are some utility tabs. There's a file explorer, much like the Windows Explorer, and there's a variable explorer, which is a graphical interface into the variables that we will have within the script. And I'll show you in more detail what that looks like. Here is the icon that sets your working folder. Your working folder is where any of the files that you're creating here are going to be stored. It's a good idea to set a working folder and possibly set up a file called pythonbasics.py if you want to follow along with this video. So let's start off with the traditional hello world. What we're going to do is actually type something here, and we're going to say something like hello world, and this is going to ask Python to do something. The way that we ask Python to start doing something is we hit on this green button here, or we hit the F5. That passes this code to Python, and we'll see some output here. So let's hit F5, and we see here that Python basics.py is being executed, and once it executes, there's an output here as we've identified here. Now this is really telling Python, hey, take what's between these parentheses and with these quotes, please, and put it out onto the console. If I've modify this and I hit execute again, I'll see that it changes. Now this print is not really a Python command, it's actually a Python function, and we'll be coming back to Python functions a little later, but this is something that you're going to be using quite heavily, especially for assignment number 1, variables and data types, and then we'll go into loops, functions, conditions, input, which is user input, and then we'll put it all together into one tiny little menu, a little script that creates a menu system, and we'll see all working together. So let's start off with what we see here. Here what we see is a hashtag, and if I were to leave this script empty and hit F5, it would do nothing. This hashtag is telling Python that whatever is to the right of the hashtag should be ignored. This is a single line commenting code. Is basically used to comment the code that you have here. Now if your comments that are a multi-line, you want to include more than one line, you use these single quotes 3 times, right? And I can say this is me documenting my code, and then I can close it off with these 3 single quotes, and when I hit run, we're going to see actually that nothing happens. It runs the file, nothing happens, because Python goes through all of this stuff and sees that these are just comments and it ignores it. So this is how you comment the code. And this is going to be important for your assignments because I do expect the code that you are submitting be well documented. So let's go on to the next topic. We'll talk about variables and data types. If you're not familiar with what a variable is or need a refresher on what a variable is, a variable, the analogy that I like to use is a variable is like a bucket, like a water bucket or a pail. Imagine an empty bucket, and the bucket has a label. The label on it identifies the bucket. The label has a name, for example, my bucket, and in the bucket is stored a value, some value, and at any given time, at any given moment, that bucket can store one and only one value. So what I have here, for example, is a bucket or a variable called a, and in that bucket I am storing the value 5. This equal sign means that I want to assign to a the value 5. I want to place into the bucket a the value 5. Now when I execute the code, the value 5 is placed into the bucket, and we see here the variable explorer that there is a variable called a pops up and it contains the value 5. So here we do have that variable, this bucket set up, but there is no output. So what we want to do is that we can go back to our print statement and say I want to print a, and when I do execute, we do see that there's a 5 there. Now what's going on here, what is print doing with a? What's going on here is we're telling Python to take the bucket a, take the value that's in the bucket a, whatever that value is, and then pass it off to print, and then print it. And that's why we see the 5 here. Now if I were to change this, let's say I change this to 7, I hit F5, we'll see that over down here to the right in the console it's printing 7 because that's what's stored in the bucket. And in the variable explorer, this is just a convenient way to look at it. We see that the value has been updated. Now I can have any number of these buckets or any number of these variables. Let's say I have a second one called B, and I set it to 10, and I can print both of them. So I do something like this, I hit F5 and I'll see 7 and 10, and obviously if I change it I'll see that it changes. And now these variables, I can do some mathematical functions with them. I can say, hey, I want to take whatever is in A and I want to add it to whatever is in B. So, and I want to print that out, and I hit F5 and I'll see that the sum of the two is 18. I can also do other mathematical things. Let me just set it to something like this. I can do multiplication, and I can do division, and that should be all kind of straightforward. Now, one thing to note regarding these variables, variables have different types, meaning they have different data types. This here, a, is storing a number. It's also possible to store other types of information. Here's an example. Let's change this to X, and we'll say I'm going to store this hello world. Now this is called a string. A string is basically just a sequence of characters, right? So I have these little characters here, HELLO. I've all kind of strung them together, and that's why it's called a string. And that is now held by the variable X. And if I do this, I'll kind of have my hello world. And obviously I can change this again, and it changes here as well. So this variable X is of the data type string. There are different types of data types. The most common that you'll be using is integer, which we just saw, which is basically a number like this. The other type is Boolean, which means a true or false, and this is, for example, we can say I is equal to the value false, and we'll see how this is useful. Or another value is I have a variable and that's equal to true. I can also have another type of data called float, and let's say I've called it F, and that is typically a decimal, so I'm doing something like this. And Python gives us a way to identify and peek into these variables and have the variables disclose what their data types are. And we use a function. Again, we'll get into what functions are, but we'll use something called type. And then I pass in to the type, I give it the name of the variable that I want to figure out what data type it is. So let's start off with the first one. I start off with X, and I'm going to print out what type it is. And I hit F5, and it's telling me that the X variable is of type string, right? And we already identified that this is string. Let me see what A is, and I hit F5, and F5 is int. So we have a data type called string, and there's a data type called int or integer. Let's do the same for I, and we hit F5. We see that it says bool, which is short for Boolean. Same thing for O, and it's also a Boolean, and we'll do the same thing for f, and we see that it's a float. These are the main data types you need to get familiar with. Python is loosely typed. What that means is I can change f from a float to a string, right? And it will have no issues with that, right? With other languages that's not possible, but here it is possible. Let's see here, this to equal, and do that, and we see that actually it's changed to a string. If we're to print what f contained, we'll see that it prints the string. So so that's a quick overview of variables and data types. Now let's do a little bit more with this. Let's talk about a little bit of the math. As I mentioned, I can add numbers. I can add an int. So let's say I have an int and I set it to 5, and I have another one and I set it to 3. I can do math with this. But what if this is a string? Can I do some math with strings? And the answer is maybe. So if I take z and I add it to 5, is it possible to add this to this? The answer in the world of Python is that no, we can't do that, right? Because you can't add a number and a string. Now, what if I change this to a string and I say something like this, and this is not really going to make sense in terms of what it's saying, but it'll illustrate the point, and I hit F5 and I see that they did put it together. So in this context, when this is a string and when this is a string, the plus is not a arithmetic plus, but it's a it means in the context of a string, it means the two strings, it means to concatenate the two or to combine them into one, right? Obviously I can't. Is it possible to multiply them? And the answer is no, you can't multiply two words. But what you can do, and even if these contain numbers in them, Python would not regard it as numbers, right? Because of the quotes. Just because they're in quotes, Python ignores what's inside and treats this as some literal piece of text. But there is that one exception where I can use multiplication with some text, and say I have something like this. Do this, and this will produce this. Actually, what it means only in this context, it's an exception. Hello will be repeated 5 times. It's just out of convenience. Python has that, and I can change it to any number, and I'll see that it produces that. So the takeaway here is that variables are a store of value, and each variable has a label, the name of the variable. The name of the variable can be almost anything. It can't be a Python command, or there are some limitations to what the names can be, but for our purposes, the name can be anything. Number of cars, for example, and as long as it's not violating some syntax rules, we can name it fairly anything. So that's variables. And for data types, we use the type function to identify, if need be, what type of data type is stored in that variable, or what type of variable that is, either int, float, string, or Boolean. For variables, we need them, as we'll see, to be able to manipulate and move information around within the script. The next thing we'll look at is loops. Now, loops is the notion that I should be able to repeat a block of code or a set of code as many times as I want to without having to type that code over and over. And let me give you an example. Let's say I do something like this, and this is great, and I want to do this 5 times, and I can just cut and paste it, and I have it there, and I hit execute, and it'll print 5 times. But what if I want to do it 10,000 times? I have a problem. Right now, the problem is that I need to type this in or paste this in 10,000 times, and that's just not going to be possible. It'll be extremely tedious. And there are other scenarios where I do want to use the ability to repeat stuff over and over without having to type that code over. So loops allow us to be able to iterate through code in some fashion. In Python, we use the for command, and we set something like a variable. We establish a variable and set in and give it a list of numbers or a sequence of numbers that it will iterate through. Now, let me explain what that means. What it means is I'm going to describe or list a set of statements after this for statement, and for that set of statements will repeat over and over, and every time it repeats, this value is going to be stored in n, and this set of code will execute, and then when it comes back around, the next value will be stored in n and it will execute. Now, whether you use n inside of this block of code is up to you, or you can just loop through the stuff if you want to. So let's say I do something like this. I print hello world without using n, and I see that it executes 5 times. Sorry, it executes 6 times. So because it's starting off with 0. So this is telling Python that I want to execute this line of code 6 times. Now I can also use the variable n. Remember, every time that it's cycling through this loop here, it's changing the value of n here, and it's putting in the subsequent value here. And I do this, and I see that it says 0 to 5. If I add some more numbers here, I can do something like this, and I execute, and I see that it goes to 8. And the numbers don't need to be sequential. I can do something like this. I can kind of jump around, and I see that. And the looping here means, again, that every time I go through it. And now I can add some more code here, and I do something like this. And something I didn't really talk about is, what is this colon mean, and why is this tabbed here? So unlike a lot of other languages, this tabbing has special meaning in Python. The fact that this code here is indented has special meaning. So the colon here that we see here is telling Python that this is going to be the beginning of the block of code that I want to repeat over and over. So anything after this colon, and you see that as soon as I hit colon, the next line will be automatically tabbed for me, right? The editor tabs it, and as long as the lines are tabbed, right, all subsequent lines are tabbed, that's all going to be part of the block of code that's going to execute. And this is the block of code here that's going to execute. The minute I break the tab, so I break this tab, right, I'm telling Python that this portion is not going to be part of the loop anymore, and any subsequent code from here on is not part of this loop. So this is what's going to execute in the loop. So if I execute that, I'll see that it's looping, and then I have the I'm done at the end because the looping is done. It gets through these numbers, right? So this structure here is called a list. We go over what lists are in a separate video, but it should be clear that it's kind of like an array. It's kind of like this sequence of numbers that we can kind of like go through, and with a loop I can go through them one by one. Now let's say I want to loop from 0 to 1,000. What do I do? Do I now go all the way up and type all the way up to 1,000? That's going to be quite tedious. There are some utility functions that Python provides. One of them is called range, and I use it to create that kind of bracketed list that was just there, but it does it for me, so I don't really need to type it in, and I can specify what number I want it to start from and what number I want it to go to plus 1, right? So if I wanted to go from 0 to 1,000, I need to put in 1,001 here, and then I put in the colon. There's that familiar colon again, and I'm saying print n. Anything that's going to be indented here is going to print. So if I execute, I see that it prints to 1,000, right? And it'll start from 0. Just see that here, that it starts from 0, and it goes up to 1,000. So this allows me to actually create that bracketed list without having to type it in. And you can see that I can loop through something, a large set of numbers very quickly, and loops are going to be useful for things like if I want to go across every pixel in a very large image, I can kind of loop through each pixel, row by row, column by column, and those are kind of the things I might be using loops for. Now if I'm going to loop, and by default I'm starting from 0, I can omit the 0 like that, and let's just let me pick a smaller number and hit that, and you can see that it automatically starts from 0 because 0 is the default and therefore it does not need to be stated, and that is a way to work it. Now I can also do something like this. I can perform mathematical functions on this. Let's say I want to multiply by 3, and I do this and I see that it's all multiplied by 3, and this can be useful. So this is kind of like kind of things that you use when you're building algorithms. So that's loops. Loops again are used to be able to iterate through a block of code some number of time, and is useful in the cases where you're looping through a lot of information. In the case of data, you might be looping through rows of CSV records and so on and so forth. Now functions are a way to take a block of code, and we already talked about what a block of code is. It's just a set of lines of code, and give that code, that set of line, a label, just a name, right? So that we can refer to that name every time we want to execute that set of code. We just use that name. So the way we do that, we use the def command, which means define, and I'm going to define a function. So let's just say my first function, and I'll go over what this parentheses means in a few minutes. And here is again our familiar quote, and I'm defining a function and I'm calling it my first function, and then I'm going to state what that function does. So it's going to do it's just going to say hello, and then it'll say, so let's say, see ya, yeah, and this is kind of silly, but you get the point. And you see that this is indented, so that means these lines that are indented are part of the function. The minute I break the indentation, I am no longer putting in lines that will be part of that function. Now when I execute this, I go this, I see, well, what happened? I don't see any hello or see ya. That's because the function is being defined but not being used. The fact that it's defined is great. It's sitting in memory. Python makes it available for use, but I need to call it or use the name or invoke it. So I invoke it by actually using its name, and when I do that, I'm telling Python to actually call the function. So when Python runs through the code, it registers this function and says, okay, well, this label is associated with this set of code. Great, I'll store it in memory. Let me know when you want to use it. And then when it gets to here, we see that we actually do want to use it, and it executes. And I can call the function any number of times. Here I'm going to call it twice, and I execute, and we see that it executes twice. I can always mix this in with a for loop. I want to, let's say, execute this function a few more times. So I do something like this, and then I tab this because I want it to be part of the loop, and I hit F5, and then we see that it's repeated 5 times. Every time this function loops, every time this for loop loops around, this function is called and it executes this. So that's kind of the basics of function. Now functions can take values, take information. It can have information sent to it, and it can send information back. You can think of a function like a black box. You give it information and it gives you information back. It might process the information that you send it, and it will send you back some results. So let me give you an example, and this is where these parentheses come in. This is where we use this is how we have the ability to send information in. Think of these parentheses like a gateway, like a door, where you're passing information into this world of the function. And the way you do it is, let's say I call the function and I want to pass to it the number 5. I want to give you the number 5. Please do something with this number 5. And what I need to do in the definition of the function is to set up a variable that can capture that 5. So let's say I just set a variable, and I can give it any name, just say num. And when I call this function, this value 5 is placed into this variable num, into this bucket num, and then this bucket num is available within this function. So I can say something like this, say num times 3, and I do that, and I hit F5, and I see that it multiplies whatever I passed in by 3. Now I can use this over and over. And this should start to make clear to you the value and the use of functions. I can say pass, let's say I pass in 9 and I pass in 2, and we can see that it's doing this. And if I get rid of this, I can see that it's printing this out. So I'm able to pass information into the function, and this allows the function to operate on different sets of data because I'm passing in things to it. I can also pass more than one thing to it. Let's say I call this function multiplier. Let's just call it multiplier. And all it does is multiplies numbers for me. And I'll just use it once here. And I'm going to pass to it 2 numbers. So I'm going to create 2 variables. I'm going to call a variable, the first variable num1, and I'll call the second variable num2. And I'm just going to print num1 times num2. Right? So I'm just multiplying it. And let's do this a couple of times. Just say 3, say 5, and execute this, and we see that it works. So this is a little bit of, this is a function that has some utility to it. It actually does a little bit of work for us, and we can call it whenever we want. I can actually increase this. Let's say I want to have 5 numbers that it takes in, and I want to multiply this by those 5 numbers. E, right? And then I can, let's just say 1, 1, 1. Right, and it runs it for me, and if I change this to 2, the value, the amount should just double. Right, if I change this to 3, it will quadruple, and there you go, triple. There you go. So now this gives you a little bit of a perspective around the usefulness of functions. Now, as I stated earlier, functions can send back information. The way functions send information back is through the keyword called return. That means, hey, I want to send information back, even though whether I've received information or not, I can always send information back. A function can always send information back. So let's say I do this multiplication, but I store the information in a variable called x, and I can say, hey, whatever is in x, I want to send it back. So now by sending it back, when I call multiplier, when I'm calling multiplier here, and I'm passing this information, it does the calculation, it returns back whatever's stored in x, and when it's returned back, it's stored into z, and it's available to z. So if I print z, I'll see that I will have that same 60 there, right? And this way, functions are kind of these blocks of code that you can communicate with. You can pass it information, and it can pass you back a result if you're doing some stuff. And the results can be, it can be an integer. Later you'll see that some of the results can be a list or other kinds of more advanced data structures. However, the important concept here is you're kind of treating functionality logic as a black box. You're labeling it, and you can call that label, and it'll do whatever it's in here, and you can always pass information back. Now the next thing we'll look at is conditions. Conditions are Python commands that help us determine if code should or should not be executed. The most common condition that you're going to be using is called the if, and if evaluates if a condition is true or not, and then determines what set of code should execute. So let's say I have a variable, let's make it a little bit more elaborate. Let's just say hungry is 1, and I say, well, if hungry is equal to 1, and I'm using these double equal signs, which means is it equal to 1? If it is equal to 1, then I'm going to do the following things, and there's the colon again, and there's that indentation again, and I'm going to define here, or I'm going to write out here the code that I want to execute if hungry equals 1, right? So I can put something here like, yes, hungry is 1, and if I execute it, we see that it's 1. If I change the value of hungry to 2 and I execute it, we see that it's nothing, because this portion determines that this is here is false. It evaluates this and determines that it's false, and therefore does not execute this. Now we can also expand this. Let's say I do something like this. I put it back to 1, and I say thirsty equals 1, I can say something like and. I can do these Boolean conditions and say, well, and if thirsty is equal to 1, then I want to do this, and thirsty. And I execute that, and it turns out that it's true. They're both true. With an and, I'm required to have these both to be true. The minute either one of these are not true, this entire condition turns to false, and this does not execute. So I hit F5, and you'll see it's not executing. I can change this to an or, and with an or, as long as one of these are true, this line will execute here, and you can see that one of them is true, and so it executes. If I change this to both to 2's, we'll see that it's not, none of these are going to be true, therefore this line does not execute. So in the Thinking Python book, you'll see a lot more detail on using the if statement. There are ways to actually handle alternatives using what's called else. So let's say no, it failed, and we can use that here, that, and execute that. And you can read more about that in the book. But this should give you a fair idea of how do we use if in Python. The other condition statement that we use is called while, and it is the keyword while, and then you have here some condition that, just like in the if statement, that needs to evaluate to true. As long as it's true, a block of code underneath it executes. So it's kind of like a combination of an if statement and a loop. Let's say I have a variable here called hot, and we could say it's true. So I'm going to check if hot is true. If hot is true, then I want to execute the following code. I'm just going to say it's hot. The difference between this and the if then is that, however, once it finished executing this block of code here, there's a block of code here, it will go back up and loop again and check if hot is true. Now the way this is set up, this will repeat indefinitely. It'll just go on forever and ever. So I'm not going to run it because hot remains true, and it just prints it's hot. It goes back and says, well, is it hot true? And while hot is true, just print this, and it goes back out over and over. So then the question becomes, is how do I break out of this kind of infinite loop? I can use kind of a flag. Let's say I do have a number that I set in an integer called temp, and I set it to something like 70 degrees, and I can check if the temperature is below, if temperature is below 75, then I can say that actually it's not hot, and I'll set the flag of hot to false, and that will cause this while loop to break. So let me execute that, and we'll see that it prints it's hot once, and then it checks if the temperature is at below 75. It finds out that this in fact is true, and it changes hot to false. It goes back up here to try to evaluate this again, and finds out that hot is false. And if hot is false, then this while loop is done. And then we can re-illustrate that by putting in here done, and execute that, and we see that it's done. So that's a little bit of an overview of using while. The next thing we want to look at is how do we get user input. This is kind of straightforward. We use, and let me just clear the screen here. We're going to use a function called input. These are built-in functions that Python has when you install Python. Python has a set of functions that are kind of pre-made and ready for you to use, and one of them is input, that allows you to take allows a user to enter some value, and it waits. Python waits at the console to allow you to input that value. And so let's say I do the input and I execute, and what I'll notice is that actually Python is just sitting there and waiting for me to input a number. Let's say I put in 10, and then it goes on, and Python lets me proceed from there. However, it hasn't done anything with it. That's because I've provided the number, I've given it an input number, but that number is not stored anywhere. So let's say I store it in a variable called, let's just call it selected, and I put it there, and then I want to print what's in that variable, and I'm printing selected, and I execute that. Again, it's asking me for input. I put in this time number 8, and it prints out the number 8, meaning that whatever I typed in gets stored into the variable. And this is useful because then I can use this kind of capability to like ask the user for information. I might ask them for 2 numbers and then multiply it using a function and things like that. So the ability to input is going to be important, especially if you're building a console-based application, which is assignment 1. Now let's put it together. Let's say I do want to build a simple trading system. Let me just build the menu, and I'll kind of use a lot of what we did here. So let's say I have a function that just shows the menu. So let's say I do something like this, and I want to trade. Second thing I want to do is show the P&L, and then the third thing I can do is quit. Right, and that's my menu. When I run it, nothing's going to happen because it's just storing the definition of the menu. Now when I call it, the menu shows up. Now what I want to do is take an input from the user and have them select one of the 3 menu items. So what I'll do is I'll use a while loop. The while loop means that, hey, as long as I'm not getting somebody to quit on me here, they're not picking 3, I want to keep showing the menu. If they pick 1 and 2, they can pick 1 and 2. I'll execute it for them. I'll do something for them. But when it's done, I want to come back and show them the menu. So let's say I have a flag here. Let's say we call it done equals false. So false, and I can use the not command, which is kind of like a boolean. So while it's not done, right? Not means here the opposite of whatever is in this variable. In this case, it's false. So that means while this is true, this whole thing is going to be true. I want to show the menu, right? And I want to whatever is selected. I want to show the menu, and then I want to get input from the user, and it's stored in a variable called selected. So and then I want to see what's in that variable. If what's selected is equal to 3, which is the quit, then what I want to do is I want to flip the flag to true. That means I want to get out of this loop. Otherwise, I'll go back and keep showing the menu. And then I can do something like this and say thank you for trading with us. And I'm done. And I hit F5 and I hit 1, and it goes off and let's say it does something theoretically, and I did 2, but if we hit 3, it quits and it's done. So this kind of shows us how we're able to use functions, how I'm able to use an if condition, how I'm able to use a while, and I may be able to have other kinds of capabilities here. So if I say, for example, if selected equals 2, then I might have a function to actually show the P&L, right? And so I might have a function here that says show P&L, and this kind of dummy thing here showing P&L, and it shows it. And so I have multiple functions, and I'm running this here. Oops. Run this here. I hit 2, it's showing the P&L. Hit 1, and I hit 3, and it quits. So this is a quick overview of the Python concepts. This should get you kind of familiar really rapidly, so then maybe when you're going through the book, you have a little bit of context and you can get through the material a little more quickly, and maybe you can get started with playing with code right away with the Spider IDE.